Today's discussion will deal with square matrices. So we talked about square matrices in the very beginning. I said I don't really need to tell you the definition. You could figure out that we have the same number of columns as rows, but square matrices are special, okay? And today we're going to talk about what we can do with square matrices, okay? The first thing we're going to talk about is an identity matrix. An identity matrix is a square matrix that consists of ones along the diagonal and zeros everywhere else. The example that I have up on the board is the identity matrix of order 3, since it's a 3 by 3 matrix. If we're talking about multiplication, do you remember which number? Like multiplication of integers, right? What is the identity of multiplication if we're talking about numbers? What? 1. Why? Well, what's true about the number 1 when you multiply? Which is why it's hidden. Okay? So when we multiply numbers, when we multiply by 1, we get the same number, right? The identity matrix has that same property. If we take a matrix times the identity, we will get the same matrix. So we call the identity matrix matrix I, and if this is confusing between ones and i's, and you know, if you need to put the little bars on it, you can. Okay? My font just didn't do that. So the identity matrix, square matrix, diagonals of ones, zeros everywhere else. When we multiply the identity matrix, in whichever order to a matrix, you should get the same matrix as a result. Okay. All right, so that's good for us to keep in the back of our brains. Okay, let's talk about an inverse. Okay, when you hear the word inverse, what do you think of? Like if we're solving equations, what do you think of when you say inverse? Fractions? Why fractions?
Just like the inverse of a fraction.
Okay. You're flipping it. Canceling each other out. I like that. Inverses cancel each other out. Okay. Keep that in the back of your brain too. So an inverse matrix has to be square. And if there is an inverse for a matrix, then when you multiply the matrix times its inverse, you should get the identity, right? They should cancel each other out in the matrix world.
When you get inverse functions, they both equal x.
Mm-hmm. Right, and kind of like if we're talking about numbers, like 1/2 times 2 is 1. A times A inverse is the identity. The identity matrix is kind of like our 1 in multiplication. Now, only square matrices can have inverses. If it is not square, there's no need to even try. Okay. And not all square matrices have inverses. Okay. So first of all, it has to be square, but that does not guarantee that it will have a matrix or have an inverse. Okay. The inverse could be undefined, which would be sad, but that's okay. Okay. Now I'm going to teach you how to find a 2 by 2 inverse by hand. And I expect you to be able to find a 2 by 2 inverse by hand. Okay, you're going to have to use it often. I am not going to show you how to find a 3 by 3 by hand. That we're going to have to resort to our calculator, but I will show you how to do that in your calculator. Okay, so let's first talk about how to find a 2 by 2 inverse by hand. All right, what I want you to do is just copy this down. Copy down A and copy down A inverse, the formula, and then I'll talk through what it all is, okay? And how to remember it. Okay, so in our 2 by 2 matrix, A, B, C, D, what I want you to notice first about this calculation right here. So we have a fraction, 1 over this weird little thing, okay? This calculation is A times D minus B times C, okay? I like to look at this and say it makes like a crisscross pattern, right? So I like to say, when I make this calculation, criss minus cross. That helps me remember the order in which to do things. Okay? A times D minus B times C. Okay? Now, along that same pattern, notice where A and D are here in our crisscross pattern. What happens over here? They switch. Okay? So we have to switch along that diagonal. The cross of our crisscross pattern, what happens over here? They're opposite, okay? So we switch A and D, and then we negate B and C, okay? I know that you can make all of these calculations. It's just a matter of remembering how to do it, all right? So we have to practice for sure in order to be able to remember this. So the first example we're going to do is we're going to find the inverse of 3, negative 1, negative 2, 2. So if we want to find the inverse, we need 1 over criss minus cross. If we take our criss product, what do we get? 6 minus cross. What's that product? So we have 6 minus 2 times, follow our pattern, we're going to switch 2 and 3, and we are going to negate negative 2 and negative 1. Okay, so So what is that constant that is being multiplied to the 2 by 2 matrix we have written there? 1/4. So we have 1/4 we need to multiply through. 1/4 times 2 is 1/4 times 1. 1/4 times 2. And 1/4 times 3. Here is our inverse. Okay, is that a strenuous process? I would not say so, but what do you have to do? You have to remember how to do it, okay? So practicing in your homework tonight, practicing this weekend as you review for the quiz, important things. All right, please write down this matrix right here. 3, -1, -6, 2. So A inverse. We're going to take 1 over Chris minus cross. And just for good practice, let's just remember that we would switch 2 and 3, and we would negate -1 and -6. Now, what's the problem? Okay, we cannot divide by 0. All right? Since we have an undefined number being multiplied to this matrix, what do you think that means? Okay. Is there an inverse for 3, -1, -6, 2? Okay. So the inverse does not exist. It's asking us to find an inverse. That inverse does not exist. And remember, I told you that can happen. Okay? It is possible for us not to be able to find an inverse. Two by 2, got to do by hand. 3 by 3, I'm not going to teach you by hand. All right? But I am going to teach you how to use your calculator. So go ahead and get your calculator out. Okay, so we are going to have to input our matrix into the calculator. Whoops. So what I need you to do, before I tell you the instructions, let's at least put this in our calculator. All right? So as a reminder, you need to go to your matrix menu. Edit. You probably already have something in matrix A. Just change it to be the 3 by 3 matrix that you see up on the board. Okay, everyone have the right numbers in? Go ahead and exit out, second click to get back to the calculation part of your calculator. What I'd like you to do is I'd like you to call up A. So second matrix, call up your matrix A. And if we want the inverse okay, we notate inverses with the -1 exponent, right? Which is this button right here that you push for matrix menu. So if you click that button, it'll give you that -1. Okay, that means inverse. You have A inverse. There's your inverse. Right? Now, watch this. If I take A and I multiply it by A inverse, what should we get? We should get the identity. There it is. Pretty sweet, right? Okay. Now, I do have this note up here on the board. Okay. If you get fractions, I do want you to change, or if you get decimals, I do want you to change them into fractions so that you can see your matrix on the calculator. Okay? Do you remember how to do that? Okay? Math. Okay? If you go to math, fraction, it'll change them into fractions. Now, they don't have decimals, so it's not going to do that right there, but I need you to know that's how you would do it. Okay? All right, so what's the point of knowing how to find an inverse? That's what I'm going to tell you, huh? Any issues with the calculators before we move on? Yeah? Okay. Maverick? Figured it out? Awesome. Go ahead and write down the system of equations. We are going to use an inverse matrix to solve this system of equations. Okay, so this is what we can do. We can create a matrix equation out of this. So Tuesday, well, Monday and Tuesday, right, we wrote this in an augmented matrix form and we did row operations to solve it. Different way, this is the second way in this chapter alone I'm teaching you how to do this. There will be a third. So you can write what is called the coefficient matrix. So just take the coefficients from x, y, and z if applicable. You're going to multiply it by your variable matrix. And it will equal your constant matrix. Okay, so let's see why this works. If we take row times column, we get 1 times x plus 2 times y, and that should equal to entry 7. Row times column, 2 times x plus 1 times y, and that should equal the 8th entry. Okay, so those are our systems of equations. Now, I'm going to give these names. Okay, I'm going to call this matrix A, this matrix X, and this matrix B. Okay. So what we have is we have A times X equals B. Now, how do we like to solve for X? Like if those were numbers, what would we do? We would divide by A. Have I taught you how to divide by a matrix? No. So instead of dividing, what would our option be? Multiplying by the inverse. We need to do the inverse operation to get it to go away. So we know if we multiply A inverse times A, and they should cancel out, right? Well, if I'm going to multiply A inverse on the left side, I also have to do it on the right side. So A inverse times A will cancel out, and our variable matrix will be A inverse times B. Okay? Now, it does matter that I put A inverse to the left of B, because I put it to the left of A here. If you put it on the other side, you're not going to be able to do the calculation. So, what we need to do is we need to find A inverse. Okay. A inverse. 1 over, what is our Chris product? Minus cross. What? 4 times. We're going to switch 1 and 1 and negate 2 and 2. So we have 1 over negative 3 that we're going to multiply to our switched around matrix. So our inverse is negative 1/3, positive 2/3, positive 2/3, negative 1/3. Okay, so I'm going to come to this step here. All right, that matches that step. Now we need to multiply both sides by A inverse so that we can get our variable matrix. Now we know that A inverse times A is going to be the identity. All right, so is it necessarily to write that calculation down? I don't think so. Okay, I don't want to get it too far. So what I'm going to do, when we multiply A inverse to the left side, do you want me to write that down or not? You don't know? No? Are you okay with me writing that x times y equals our inverse times b? Okay, since we have it written right here, I don't feel it necessarily to take the room to write it in matrix form. Okay, so now all we have to do is multiply these two matrices together. We have a 2 by 2 matrix that we're multiplying to a 2 by 1 matrix, which means we're going to get a 2 by 1 matrix. We are taking, oh, that went a little bit too far. We are taking negative 1/3 times 7, and we are adding it to 2/3 times 8. Okay, for our second entry, we're taking 2/3 times 7 and adding it to negative 1/3 times 8. What is negative 7/3 plus 16/3? 9/3, which is 3. And what is 14/3 plus negative 8/3? 6/3, which is 2. So our coordinate of intersection is 3, 2. So by using an inverse matrix, we can solve a system of equations. So now you have two ways a matrix can help you in solving for systems of equations. We have an augmented matrix, and now we have a matrix equation, is what I'll call it. Okay. So let's go ahead and try to solve a 3 by 3. Now, you're given a 3 by 3. Do you know how to find a 3 by 3 inverse by hand? You do not. Okay? So if you want to use a matrix equation, if it is 3 variables, your only option is with your calculator. Okay, so you need to keep that in mind if you're on like a non-calculator portion of a test or quiz. Okay, so go ahead and write this down so that we can make the calculations here in a moment. So what we would create is a matrix equation. We would have the 3 by 3 matrix of 2, 3, 1, 3, 3, 1, 2, 4, 1. Okay. We would multiply by our variable equation to get our constant matrix, -1, 1, -2. This would be our matrix equation, okay? And much like before, we could call this A times X equals B. And in order to be able to get X by itself, we would have to multiply both sides by A inverse so that we could solve for that matrix or that variable matrix. Question? Something? Okay. So this is what we're going to do in our calculator. Turn off on mute. Okay, so you're going to have to edit 2 matrices. First, you're going to edit your matrix A to be the 3 by 3. Then you're going to have to go back into your matrix menu and edit B to be what kind of a matrix? 3 by 1. So you have a 3 by 3 matrix for A, a 3 by 1 matrix for B, and here we've done the algebra, right? AX equals B, multiply both sides by A inverse to get that our variable matrix X would be A inverse times B. So in your calculator, all you're going to have to do, you're going to call up matrix A and make sure that it's your inverse and multiply it by matrix B. So 2, -1, -2 would be our coordinate of intersection here. So today you don't have a choice. I need you to solve these using matrix equations, okay? I will talk more tomorrow about when you will get to make a choice of an augmented matrix versus a matrix equation. Now, if you don't have your calculator and it's 3 variables, you wouldn't have a choice. But if it's a 2 variable and you don't have your calculator, you would have a choice. Okay, with your calculator, you might have it close. So we'll talk about that more tomorrow as far as what to expect on the quiz. But what I'd like you to do in our last 10 minutes of class is go ahead and start your homework. I'd like you to practice a couple of these before I send you on your way.